Hello grade 6. Welcome to first part of our review for our second term final exam. Let us start with absolute value. I know this is one of the easiest lessons that we have, and you can answer it perfectly. Let us start. What is the absolute value of 3? That is 3. Absolute value of negative 10? That is 10. Absolute value of negative 5? It's 5. And absolute value of 0? That's 0. So as you have noticed, and if you can remember, all our absolute values are positive. Why is that? It is because the absolute value is its distance from 0 on a number line. And remember, we don't have a negative distance. Now let us compare absolute values. When you compare absolute values, be sure to answer the absolute value first before you compare. Like this one, we have absolute value of negative 5 and 5. So let us first answer what this absolute value of negative 5 is. And the absolute value of negative 5 is 5. And then now let us compare. We have 5 and 5. That means they are equal. Next, we have absolute value of negative 18. And that is 18. Compare that 18 to 16. That is greater than. So that is how you compare absolute values. Be sure to answer the absolute value first before you compare. If both numbers are absolute values, then find their absolute values first and then compare. Now let us have rational numbers on a coordinate plane. So I have here a coordinate plane and I have 2 points. So we are going to put the ordered pairs for each point. We have here point A. So what are the coordinates of point A? First, look at the x-axis. So this is the x-axis, the horizontal number line. Where is it opposite? So point A is opposite 2 on the x-axis. That means the x-coordinate is 2. So we put the ordered pair in parentheses. So the x-coordinate, which is the first coordinate, is 2. Now, the y-coordinate or the second coordinate is the number opposite in the y-axis or in the vertical number line. So this point is opposite 2 also in the y-axis. That means the y-coordinate is 2. Now let us have point B. Again, look first at the x-axis. Where is this point opposite? So that is opposite negative 3. So that means the x-coordinate is negative 3. How about the y-coordinate? So it is opposite negative 4 in the y-axis. So the y-coordinate is negative 4. So that is how you plot points in the number line. Now let us plot points C and D. Point C is at point 4, 1. So again, the first coordinate is the x-coordinate. So look at the x-axis. So 4 is here. So just remember that. Do not put the point there yet because that is just the x-coordinate. And then the y-coordinate is 1. Since it is positive, that means you will go up. So from that point, go up once and that will be point C, which is 4, 1. How about point D? So the x-coordinate is negative 3. That means from 0, we will move 3 to the left since it is negative. Or find negative 3 in the x-axis. So there is negative 3. Remember your point there. And then the y-coordinate is positive 2. That means you'll go up 2 units. So 1, 2. That is opposite 2 in the y-axis. So our point will be there. And this is point D at negative 3, 2. We also discussed ordered pair relationships. Do you remember that we have 4 quadrants in the coordinate plane? The first quadrant is found on this region, which has positive x and positive y coordinates. So if the x and y are both positive, you can find the point at quadrant 1. Quadrant 2 is on this region because from quadrant 1, we will be moving counterclockwise. And the x here is negative and the y is positive. Then we have the third quadrant in which both coordinates are negative. And the fourth quadrant in which the x-coordinate is positive and the y-coordinate is negative. So for example, we have the ordered pair -2, -3. So since both coordinates are negative, that means we can find this in quadrant 3. If we have 2, 3, having both coordinates positive, that means it is at quadrant 1. If we have -1, 5, so we have negative, positive, then that means this point is at quadrant 2. And if we have 5, -1, we have positive, negative, that means this point can be found in quadrant 4. We also discussed that points can be reflections of each other across x or y axis. So remember the technique that I told you? If the x coordinates are the same, then they are reflections of each other across the x-axis. If the y coordinates are the same, that means they are reflections of each other across the y-axis. Let us have an example. If we have -5, 9, and -5, -9, so x are the same, y are opposites, that means these 2 points are reflections of each other across the x-axis. If we have 2, -6, and -2, -6, so x are opposites and the y are the same. That means they are reflections of each other across the y-axis. Now let us have distance of points on the coordinate plane. Let us have an example. We have -3, 2, and 5, 2. So think where you can find -3, 2. In which quadrant is it? That's right. That is in the second quadrant. How about 5, 2? 5, 2 is at the first quadrant. So the coordinates that are different this time are the x coordinates, right? Because the x coordinate here is -3 and the x coordinate here is 5. And they have the same y coordinates. So we also know that these points are on different quadrants. If the points are on different quadrants, then you are going to add their absolute values. If the points are on the same quadrant, then you are going to subtract their absolute values. Now, which numbers are we going to look for their absolute values? The coordinates that are different. So, we have -3 and 5. The absolute value of -3 is 3. The absolute value of 5 is 5. Then you are going to add the two absolute values. That will be 3 plus 5, and that will give you the distance of the points in the coordinate plane. That means the 2 points have a distance of 8 units. Now we have here -6, 3 and -1, 3. So by looking at their signs, we know that they belong to the same quadrant. That is at quadrant 2. So -6, 3 and -1, 3. So 3 and 3, the y coordinates are the same. That means we will be getting the absolute values of the x coordinates, and then we are going to subtract. Why are we going to subtract their absolute values? Because the points are on the same quadrant. So absolute value of -6, that is 6. Absolute value of -1 is 1. Then, since they are at the same quadrant, then we are going to subtract their absolute values that give us 5. That means their distance is 5 units. And that's it. That ends our first part review of our lessons for the final exam. See you in part 2 of our review. Bye!